This is part 1 for lesson 10.4, reflections and rotations. Okay, just by way of review, the translations that we learned about before. So just to review this, if you want to pause the video and just turn it back on when you make sure you've done the translation correctly, and then we'll move on. Okay, what you should have done is you should have just translated like this. So you can see where I've got A prime, B prime, C prime. So just make sure you've got that, and then we're going to go on. So the vocabulary at the top of your page, we're going to talk about a couple of them right now. We're going to talk about congruence. So of course, as you know, congruence is the same size and same shape. We use this symbol. And so that's something can fit right on top of the other. There's no overlap or anything like that. Also in isometry, that preserves the congruence. And translations we talked about last time, we're going to right now talk about reflections. And so with reflections, it does preserve that isometry. So for a line of reflection, or for what a reflection is, it's also known as a flip. And so if you think about a pancake flipping, but that's what it is. So if you've got something like this and you flip it, it's going to be like a mirror image. So something like that. It does preserve the congruence. And what we have when we do a reflection, we always have something that has to be reflected across, so like your mirror. And so we're going to have this line of reflection. And so if you think about it, like if you're standing here looking in the mirror, so this is the mirror, what do you see? You see yourself looking in the mirror, same size, same shape, same distance away from the mirror. And so we're going to use that idea. But every point on the pre-image, so if your eyeball is this far away from the mirror, then the eyeball of your image is that far away from the mirror as well. And so every point is equidistant from the line of reflection. Here is the key though. The perpendicular bisector, so the perpendicular bisector, if you have a segment, the bisector is going to go through the midpoint. So you can have a lot of different bisectors, anything that goes through the midpoint. However, the perpendicular bisector means that it's going to be perpendicular and going through the midpoint, which means this piece is congruent to this piece. It's got a 90-degree angle, so their slopes are perpendicular, so opposite reciprocals. We'll talk about that as we do it, but this is the key right here, that the line of reflection is the perpendicular bisector of the 2 points joining the pre-image and the image. So if I look again at my example of me looking in the mirror, you've got this line that connects me and my image, and then the mirror, or my line of reflection, is going to be a perpendicular bisector, meaning it's equidistant and it's perpendicular. So that's the key to knowing that you've reflected correctly. So we're going to start practicing here with this one, and we're going to start with reflecting across the x-axis. So the x-axis is going to be my mirror. And you have done this before. When you have n, like if it's on the mirror, then that's also going to be n prime as well. O, it's 1, 2, 3 away from my mirror, and so I'm going to go 1, 2, 3, and so this will be my O prime. And so I don't want all the little shapes there, but I'm just showing you where I'm counting. M prime is going to be right here because it's going to be 1 away, and then Q prime, you count 1, 2, 3, 4, so 1, 2, 3, 4. So as long as your line of reflection is perpendicular, it's pretty easy to do a line of reflection or reflect across a line. And so reflecting across the x-axis and the y-axis is not very difficult. Now, one thing that you should do is to check your reflection. If you'll pick up your paper, and I want you to fold it on the x-axis. So literally pick up your paper, and I want you to fold it on the x-axis and just see. It's kind of like you have butterfly wings. Oh, and I'm just noticing that I missed a point. That's kind of bad. Okay, I missed P. So let's see, that's 5 away. P prime. Okay, that's going to make a different shape altogether. So that's one of the reasons why we do this next step I'm about to show you. So you want to fold it, and you want to make sure that all of these points, like butterfly wings, like this point is kissing that point, and this point is kissing that point. And so you want to make sure that everything is fitting together, because if it doesn't fit together, then you did not do the reflection properly. Now, talking about that whole perpendicular bisector thing, if you were to draw a line connecting O and O prime, like that, you can see that the distance there is 3 and the distance there is 3. So this is the midpoint. Also, this line connecting the two is vertical, and the line of reflection is horizontal, and so you know that they're perpendicular. So this is the perpendicular bisector. Now that's not really a big deal when you're reflecting across an X or a Y axis, but when you start reflecting across lines that aren't an X and Y axis, that's a really important thing to know. Let's answer some questions down here below. 2a, so how far is n and n prime from the line of reflection? So they're both how far away? So n and n prime, if I look at that, they're both 0 away, same distance. How far p and p prime? So 1, 2, 3, 4, 5, and p prime is 1, 2, 3, 4, 5. So they're the same distance away also. What about q and q prime? 1, 2, 3, 4, 1, 2, 3, 4. So they're both 4 away. So what I'm trying to emphasize here is that they're equidistant. So write that word down, equidistant. And so the pre-image and the image are equidistant from your line of reflection. Okay, let's practice another one. This time we're not going to reflect across our x-axis. That's what we did last time, but we're not going to do that this time. We're going to have a different line of reflection. This is going to be my line of reflection. So the first thing you need to do is get a straight edge, and you are first going to draw your line of reflection. So the line y equals -2. So that's going to be this horizontal line that goes through the y-axis at -2. With a straight edge, you're going to draw that line. Okay, so make sure it's nice and straight. Just FYI, I can't use a straight edge on this video platform I'm using, so I'm doing the best I can with that, but you can, so I do expect you to. Okay, so then you're going to look at the red line, what I have here. That's going to be your mirror. So if A is looking in the mirror, it's got a distance of 2, so A prime is also going to be 2 away, just in the opposite direction. Same with D and D prime. And then C, you're going to count how many it's going to take to get to the mirror, and I'm counting 6. So that's going to be down here. And so, like I said, when you're doing horizontal and perpendicular, it's really pretty simple. Okay, and you have done with the horizontal and perpendicular, you have done that before. Again, straight edge right here. Okay, so this really should be a review for this part of it more than anything. So just to emphasize, this distance right here is the same. So this is 2 and this is 2. Same with B and B prime. Same with C and C prime and D and D prime. Not only that, all of my green lines are vertical and my line of reflection is horizontal. So I know that we've got perpendicular lines, and so since they're equidistant, they're perpendicular bisectors. So this red line is a perpendicular bisector of all of the green lines. Okay, let's go to the next one. Number 4, we're going to now reflect it across a different line, so not a horizontal or vertical line. We're going to reflect it across the line y equals x. So remember that's y equals 1x plus 0. So we actually have the line drawn for you. I have it drawn for you right there. So it's going through 0 as your y-intercept, a slope of 1. And so we're going to reflect it across that line. Now, you might look at that and think, okay, well, that's not that hard. You just have to, like, you know, kind of reflect it. And that's true, but it's kind of hard to see, like, exactly how that's going to work. So what we're going to do is we're going to use that idea right here about the perpendicular bisector and the perpendicular lines. And so if I look here, my slope right there, m is equal to 1. And so my perpendicular slope is going to be the opposite reciprocal of that, so -1. So all of my lines joining, like C and C prime, are going to have a slope of -1. So that's going to have a slope of -1, that's going to have a slope of -1. And so that's going to help me, it's going to mark my pathway. And so what I like to do is I like to think, okay, I'm going to follow the pathway of -1. So I'm going to start at C, and I'm going to go down 1 and over 1, because that's a slope of -1. Down 1 and over 1. And then to get to my line of reflection, I only have to go down a half and over a half. So I basically had to take 1, 2, 2.5 trips to get to the line. And so on the other side, I'm going to do my half, and then 1, and then 2. And so this is going to be my C prime. And so what I've done is I've created a situation where the distance from there to there is the same there to there. So actually, it would be better if I just drew one line. So if I draw a line from C to C prime, this is going to be perpendicular because this slope is 1 and this slope is -1. So they are perpendicular. And I could check the distance, but I know that I went 2.5 and then half and 2. So they're the same distance. And so that way, if you use the perpendicular line idea, that makes this a lot easier than if you do it any other way. And I've tried other ways. This is the easiest way. So let's go to B. So to get from B to my line, the pathway I'm going to follow is -1, so down 1 and over 1. I only had to do one trip to get to the line, so on the other side, I'm only going to do one trip right there, so that's B prime. Okay, so see if you can do A. So pause the video, do A prime, and then come back and see. Okay, what you should have done is you should have gone down 1 over 1 and continue. That's 2, 3.5 trips. That's what I call it. I call it a trip. So when I see this, that's one trip. So I've got 2, 3.5. So I'm going to go half, 1, 2, 3. And that's A prime. So like I said, if you'll just follow the pathway of the perpendicular line, that makes this so much easier. And so get your straight edge, and you're going to connect those dots. Now, what I want you to do then is I want you to pick up your paper and I want you to fold it on this line. So literally fold it and make sure, is C and C prime, are they kissing each other? B, B prime, A prime. So when you fold it like butterfly wings, everything should match up. So you make sure, and that's how you check to make sure that you did it right, along with the perpendicular ideas. Okay, we're going to answer some questions over here, and this is just to re-emphasize the things that we've just talked about. So drawing a line segment between A and A prime, B and B prime, C and C prime. So what is the slope of our original line? We've already said that that was 1. What is the slope of A to A prime? We already followed the path of -1. B to B prime, -1. C to C prime, -1. And I know that without having to count it again because that's the pathway I followed. So how is the slope of y equals x, that's this one, related to this slope? And we're going to say opposite reciprocals. And then we're going to say perpendicular. I'm running out of space. Okay, so perpendicular. How is the slope of y equals x, so that's this one, related to b prime? Same exact thing. Now, I'm asking you the same question, but I want you to write it again. I don't want you to write same thing or anything like that. I want to emphasize, give your brain a chance to understand that it's the same thing. You can abbreviate perpendicular. And then how is the slope of y equals x, so my 1, how is that related to my slope of C to C prime? So again, I want you to write it one more time. Opposite reciprocals, perpendicular slope. This lesson will be continued in part 2.